first thing that we're going to look at is central angles. And a central angle means that it has its center point right in the center of a circle. And then it goes out and it goes out there. So that's called the central angle. And there's a little thing that says, so that's the center of the angle. So BAC is a central angle because it goes in the center. And there's a little formula that basically, it's got more words in it, but I'm going to break it down, just make it simple. That the arc length equals the angle measure. So basically what that tells me is that here is my arc, and here is my central angle, and these two things are equal in length. So if I told you right here that this angle, central angle, is 42 degrees, then this length right here, that goes from the point there to the point here, that's the arc, that's going to also be 42. So if BAC equals 42, then arc equals 42. So then we know that central angle equals arc length. Oh, that's not in degrees. So that's a nice little thing to know. They are equal if it's in the center. Now, so let's take a look at another example. Find arc length CD, so we're going to look for this. If I tell you that this is the diameter, okay, and if I know that BAC, this guy right here, is 100, so I wrote that here. If BAC is 100. So if this is 100, so a good thing to do is draw a picture and then put in the angle measures that you know. So this is 100. I want to find out what is this little guy right there. Now I know that this is the diameter. So if this is the diameter, I know that this is 180 degrees right here. From B all the way to D, that's 180 degrees at angle A. So I know if that whole thing is 180 and this piece is 100, all I have to do is go 180 minus 100, and that gives me 80. And then since the arc is the same as the angle, so I just found out that this angle was 80 degrees. So since I know that this angle is 80, and its little center point is here in the center, because that's a central angle, then the angle measure and the arc are the same. So that's 80. So I know that the measure from C to D is 80. All right, now let's see how we can do another one. So another thing that it says is the sum of all central angles with no interior common points equals 360. So basically what that tells me is that all of these together that make inside the circle are going to add up to 360 that are sitting inside the circle. That's really what that kind of means. So now let's say we are given that this little guy is my diameter and that he is perpendicular to this one right here. So QR is perpendicular to PS. And then we're also told, so here's that, QR and PS are perpendicular. This little sign means perpendicular if you haven't seen that before. And then I also know that PQ is 40. So I know from here to here is 40. And we know that QR is the diameter, and we want to find out what is the measure of PAS. So when I look at this, because these two are perpendicular to each other, in your last section you learned that if this is 40 and these are perpendicular to each other, this little guy right here is the same measure as this arc length right there. So that was back in the arc length thing. So that's also 40. So now we can use that little rule that says, hey, these are central angles. So this is a central angle, and I know that that's 40 degrees. And this is a central angle, so I know this is 40 degrees. Now I also know that this is a diameter, so I know from here to here is half of 360, because this whole thing would be 360. Since this is the diameter, from here to here is going to be 180. So since that's 180, what I can do is just go 180 minus 40 minus 40. So here's how it looks when I write it all out. But that's what it says. So since arc PQ is 40, then arc RS is 40, but because PQ was 40, then angle QAP is 40 degrees, and angle RAS was 40 degrees. But I know that angle QAR, the whole thing, had to be 180, so I went 180 minus 40, so PAS is 100. So you can either write it out like that, or draw the picture. Makes it easier, I think, because then you can see what it looks like. So I know that this is 100 degrees. And that is central angles. Okay, now let's take a look at inscribed angles. So a central angle had its little center point right here. An inscribed angle means it has its little center point sitting out on the outside of the circle, and that's called the circumference. So that's sitting on the circumference of the circle. And a little formula that we have, there's more to the formula, but I'm breaking it down and just making it like simplest words. So basically it says the measure of the inscribed angle is 1/2 the arc. So when it was sitting here in the center, the arc and the angle were the same. But if I take my angle all the way out to the side, then this angle measure will be half of this arc length right there. So the angle measure will be half of the arc length. So you can just kind of think of it as being half. So here's an example. Here's my little circle, and if D to F is 60, find angle DCF. So from here to here is 60 degrees. Hey, I look at this and I notice this is sitting on the side, and I remember that if it's sitting way out here, that this is half. So I'm going to go 60 and take half of that, and half of 60 is equal to 30. So this angle right there is 30 degrees. So you can look at the picture, or you can write it over here, and I say angle DCF equals 1/2 times 60. And when we say 1/2 of something, that's really just saying the same thing as dividing by 2. So if that's easier for you, you can do that, and that's equal to 30 degrees. Now we can also use this to find the angle measure. So when I looked at this one, I gave you the arc, and we found the angle, but now we can also use it if we want to find the arc, and we can use that angle to find the arc. So arc, if this is half of this, then if I have one of these, I just have to multiply by 2 to get that. So we can say the arc is equal to 2 times the inscribed angle. So that's only when it's touching back here. So here's an example. If DCF equals 40, so hey, we're saying that this little guy right here equals 40 degrees. So the best thing to do on these is just draw a picture, and it doesn't matter what letters you use here, as long as they would say, this would say an inscribed angle is 40 degrees. So I know inscribed means I have to come all the way there, and I labeled it DCF, and I put, hey, it's 40 degrees, and we want to find this measure right here. Well, we know that this is half of this, so this means I have to multiply it by 2 to find that measure length. So I go 2 times 40, and that gives me 80. So this is 80, because half of this gives me 40. So there we are. Now we can combine some of these ideals. And this looks trickier, but it really isn't, because what I notice is here I have one central angle because it comes into the center. And I remember a central angle means that this measure of the angle is going to be the same as this because it is the center. And I know that this angle measure will be half of this length because that is an inscribed angle. So if I tell you that the angle QAH is equal to 120 degrees, so I'm going to go ahead and draw it. So that's 120 degrees. Find the measure of angle C. So we want to find this. Well, I know if this is 120 degrees, then I also know that this arc length of QH is 120. And if my arc length is 120, then I know that this angle C is going to be half. So I just go 120 divided by 2, and that gives me angle C equals 1/2.